Okay, so last class what I discussed here. So, what is the reason to go for Hadoop? So, before that, we discussed about what is exactly web application, and even if you go with any RDBMS software, so it can be some Oracle or MySQL, right? So, each and every database it is having its own limitation. So, in the point of data. So, if you go with Oracle, so let us assume if it is store some 12 terabyte. So, whenever if you're getting beyond the 12 terabyte, so maybe some 13, 14, or maybe some 20 terabyte of data. So definitely we are not able to store. We are not able to store the that much amount of data in Oracle database. So we can say that it is a limitation. So beyond that, it was not able to store. So immediately they provide the solution called as a cluster. So nothing but we need to create a cluster with Oracle. I mean group of Oracle instance. It has to be connected within a single network. So that type of concept what we're exactly calling as a cluster. So even cluster is also having a limitation. So beyond that, it was not able to store. So simple that any software. So what are the softwares which you are using? So every software, let us assume if you go with the software as a RDBMS software. So every RDBMS software, whether it go for Oracle, SQL Server, MySQL, having its own limitations in data point of view. But nowadays we're getting the beyond the limitations of these respective softwares, that amount of data, what we're exactly calling as a big data. So you can take one more example as if you're going with a file which is having a size as 1 GB. So can we open this file with Notepad means definitely we're unable to open, because Notepad point of view that 1 GB file is nothing but it is a big data for Notepad software, but it may not be big data for Excel. Okay, it depends upon the software. Simply you can say that. Okay, but whatever the storage softwares or storage uh, RDBMS which we are using, so each and every software is having some limitation. If you are getting a data beyond that limitation, that data what we're exactly calling as a big data. Okay, and after that we have defined what is exactly big data, and even we discussed about types of big data. Okay, so let me summarize these definitions once again, and then we can go with further concepts. So what is big data first of all? So big data is a word used for gathering of data sets that are large and complex, which is difficult to store and process by using existing database management systems or traditional data processing tools. Nothing but Oracle or MySQL, these softwares. Okay, or simply you can say that this is a simple definition of big data: any amount of data that was unable to store and process by using existing traditional database systems can be termed as big data. Can be termed as big data, right? So this thing we discussed already, and after that we discussed about types of data, or we can say that types of big data. So first one is structured structured data, and second one is semi-structured data, and third one is unstructured data. Okay, so what is the first one here? Structured data. So structured data is the structured data here, the data that can be stored and processed in a fixed format is called as structured data. Okay, the data that can be stored and processed in a fixed format is called as a structured data. So here fixed format means if you're going with a structured data, so best example is Oracle MySQL databases. So whenever if you want to store some data in Oracle or MySQL, so it will store in the format of rows and columns. That is what is exactly fixed format. That is what is exactly structured data here. Okay. And what is the second one? Nothing but semi-structured data. Semi-structured data. Semi-structured data is a type of data which does not have a formal structure of a data model. Okay, semi-structured data is a type of data which does not have a formal structure of a data model. So whenever if you want to store some data in any RDBMS software, first of all we need to define a model. Okay, nothing but if you're going with the creating as tables, inserting some data, right? We need to create some couple of queries. So that nothing but what is exactly model. But if you observe the semi-structured data, it doesn't have a particular model. So first, particular model of your data. Okay. So best example is JSON, which we discussed on yesterday. Okay. And what is the last one? Unstructured data. Unstructured data. So the data which have unknown form and cannot be stored in RDBMS and cannot be analyzed unless it is transformed into a structured data or structured data or format is called as a unstructured data. So the data which have unknown form and cannot be stored in RDBMS. This is very important point. So here 90% of today's data is a unstructured data which was not able to store on our existing database management tools. I mean RDBMS software here. So first of all, we need a solution to store unstructured data. So that is the reason why we are moving for Hadoop, I mean HDFS as a storage device, and cannot be analyzed unless it is transformed into a structured data or a structured format. So first of all, we need to, after storing this unstructured data, we need to convert this unstructured data to a structured format by using some processing tools. If you're going with a Hadoop point of view, one of the processing tool is nothing but MapReduce. Okay, so by using MapReduce, so we can convert this unstructured data to structured format is called as an unstructured data here. So here best example is videos, audios, so like this. These are the unstructured data. So yesterday we discussed up to here, right? So today we can discuss some more concepts. So next thing is big data characteristics. Big data characteristics. So here, uh, why we need to store this big data first of all? Okay, or what is the reason why we are storing this much of big data? So is there, I mean, are we getting some information or some value from that respect to big data or not? So these points we can get more clarity. So once you are done with discussion on big data characteristics, okay. So the 5 characteristics that define big data are volume, velocity, variety, veracity, and value. Okay, volume, velocity, variety, veracity, and value. These are the 5 big data characteristics what we are having. Okay, so what is the first one? Volume. Okay, so volume refers to the amount of data. Volume refers to the amount of data which is growing day by day, which is growing day by day. So here simply volume. So within the word we are having a value. Volume means nothing but a amount of data, okay, which is going day by day. So here whatever the data. So nowadays if you observe in volume point of view, okay. So whatever the data which is generated by humans, machines, okay, and their interactions on social media itself is a massive. So here, if you observe the human's point of view, so daily here, what are the mobiles, I mean, or notepads, what are the devices which are using daily? So every day we are, as a humans, we are generating huge amount of data to different applications. So if you observe some transactions, some bank transactions, whether if you're going with different bank apps, so we are as a user and as a utilizing that respect to services from the banking applications, we are itself generating some logs or some transaction logs to the end of the bank application. Okay, and if you are going with some different wallets or different mobile wallets, what we're having, again wallet itself we are generating the data. Okay, or booking some movies or booking some, I mean, if you are doing some shopping on different shopping apps, so definitely as a user we are using, and at the same time the whatever the apps or whatever the apps which are using, okay, for different domains, they are also getting some they are also getting some data as we are using. Okay, so volume refers to the amount of data. So this is the best example if you take humans point of view, and if you go with the machines, right? So daily, if you observe within the traffic signals, so we're having so many sensors, so many cameras are watching us. So this is the in turn leads to a data generation and social interactions between different people. it is a one more cause of generating huge amount of data. These different uh, views, what are the views which I have told you, nothing but human, machines, and social interactions, which in turn leads to huge amount of data. That is nothing but is exactly volume. Okay, so second thing is thing but velocity. Velocity is speed at which data is generated, produced, created. Okay, velocity is the speed at which data is generated, produced, or created. Okay, so in terms of speed, so let me provide you some example. Okay, so best example is Google test or GPay. Nowadays they're calling as a GPay. Okay, so if you observe, so just assume that I want to do some transaction from Axis Bank to Axis Bank user only. So it is taking some couple of seconds. I mean, sometimes it is taking some couple of minutes to get some SMS or whether the amount is deposited or not. We, as an end user, need to check in Axis Bank app as well or different app applications. So, and sometimes it is going to generate some OTP, some authentication. All these things we require if you're going with normal apps. But if you're going with this GPay, right? So within the fraction of seconds, this transaction is happening. Okay, so I mean, it is depositing to different accounts as well. It is not in the same account. So same, I mean, amount is transferred to the different users with different banking applications, not with same applications. What I mean to say, that is the speed. I mean, within the fraction of seconds only, the data. I mean, the amount is deposited to the end user. So it is not asking any OTPs. These all these things as well. So a couple of seconds. So then nothing but a velocity. Okay, how much speed it is generating the data here. So just assume that not in a single point of user. So just take it as a globally. So within the one day, huge transaction logs is going to be generated for in GPay point of view. That is the speed. Or just you can take it as a WhatsApp as well. So now if I'm sending some image to my friend or some audio file to my friend, right? So for suppose it is delivered on tomorrow means there is no usage of that respect to WhatsApp application, right? But it is reaching within the fraction of seconds if end user is having a internet. Okay, so there is a velocity what we're exactly calling here. Okay, so third one is variety, in which you know already. So variety is nothing but a types of big data we have discussed here. Nothing but how can we handle this structured, semi-structured, or unstructured data? Nothing but a variety of data. Okay, nothing but handling of structured data, semi-structured data, and mostly unstructured data as well. So because here why I have mentioned mostly unstructured data is so there is a uh, which leads to a big data. Okay, so because nowadays we're getting only unstructured data when compared to structured and semi-structured, which leads to big data problem. Which leads to big data problem. Nothing but variety. Nothing but here main point is how can you handle these types of big data here, whether if you go for structured, semi-structured, unstructured. Anyway, we can handle by using structured and semi-structured by using different database management tools, or even you can form the clustering concept. So many ways we're having. But here the main problem we are facing is we are unable to handle unstructured data. Okay, we are unable to store before handling or before processing. So first of all, we need to store. We are unable to store unstructured data by using existing traditional database management tools. That is the main problem what we are getting. Okay, and which leads to the big data problem as well. So that is the reason we are moving for Hadoop as one of the solution to solve this big data. Okay, and veracity, uncertainty, or inconsistency of data. Okay, uncertainty or inconsistency of data here. Okay, I think, but we can say that some ambiguity. So for suppose whenever if you're getting some unstructured data, okay, so uh, if you're not crossing to the structured data, or if you're directly crossing this unstructured data, and just if you're assume that we have stored the unstructured data and we have processed this unstructured data, and finally we are displaying this data to the end user in dashboards. Just assume. So differently, if you're directly displaying this unstructured data, somewhere this information is going to be missing. So that is the reason, first of all, we need to convert this unstructured data to the structured data. Then only, so presentation is very easy for us as a developer point of view as well. Okay, that is nothing but inconsistency of data. Nothing but we are unable to analyze a particular data set which is a unstructured data. So for analyzing the unstructured data, before going for analytics, we need to go for complete data cleaning or data cleansing. What are the unstructured data we're having? First of all, we need to go for some processing tools, some cleaning tools or cleansing. What is exactly data cleansing tools? Means we can go with the Spark for complete data cleaning of this unstructured data, or maybe some MapReduce as well. So then if you process or if you display this data to the end user, so there is no chance of having some data inconsistency problem as well. Okay, and finally, what is the advantage is finally we're getting value. Nothing but business from this big data. What are the big data we are storing, right? Finally, we're getting income from that respect to big data. That nothing but what is exactly value. Okay, nothing but deriving the business. Deriving the business from the big data. So that is what is exactly value. Okay, so what are the data in which we are storing? How the companies, why they are storing this much of amount of data is, so finally they are getting the value from the data. Means finally they are deriving the business from this big data. That is the main advantage of this characteristics. What are the characteristics which are explained? Okay, so you can have some questions. Why they store this big data means they are deriving the business from the big data. What are the data in which they have stored in by using a different storage devices. Simply we can say that different storage options. Okay, so best example if you're going with the value is, so you can go with any mobile operators. If your best example if you're going with Geo. Okay, so let us assume that in 2017 they have got some data around some 50 terabyte. Let us just assume 50 terabyte. Okay, out of this 50 terabyte, first of all they need to store this data in by using some HDFS. Okay, after storing this much amount of data, they need to process this. They need to divide the data whether it's structured, semi-structured, unstructured, and they need to convert this unstructured to structured. These all these things mechanism they need to implement. But finally they have got a conclusion. So complete this 2000 year, what is 2000 year they're having. In this complete year, they have got some conclusion that so in January to March, so we have released this respect to offer, right? So this offer is purchased by huge geo users. I mean huge users. Whatever the offer which have released by Geo, so this offer is they're having a huge hit in the market. Simply you can say that this offer is a huge response from the uh, market. I mean cell phone market. Simply you can say that. But whatever the offer in which they have provided, maybe some August to September, that is not at all. It is responded not completely. Okay, so users are users taken more interest on this respect to offer some January to February or January to May or January to May or January to some whatever the consumer line January to March. But I assume January to March. So this offer is a huge hit in the market. So why can't we implement the same offer in 2018 as well? So once if they implement, so there is a chance of getting the business from this data, what are the data in which they have stored in 2017. Same offer they can implement in 2018 as well. So like this, so this is some use case. You can assume this is some use case, and this is the best example how they are deriving the business from the existing data set. What are the data set they have? We have assumed the data set as a 50 terabyte. On this 50 terabyte, they need to implement so many technologies, and finally they need to get the visualization. Finally, they need to get the complete dashboard. So if they selected some January to March, okay, so this offer we have released, and this money amount of users they have taken, and this is the complete analytics they need to get a dashboard. So like that, we need to provide a solution for this 50 terabyte of data, and finally, the Geo is going to get the business from this data. What are the 50 terabyte of data in which they have stored here? This is a complete use case on the value point of view. Okay. So is it fine, or if you're having any questions on these topics, please let me know. Is it fine? This big data characteristics. Okay, so if you're having any doubts, you can discuss in chat. We will discuss further if anybody is having some doubts on this. Okay, I hope it is fine for you. So next concept is very important concept here. What is the reason to go for HDFS? What is the reason to go for HDFS? So here HDFS is nothing but Hadoop distributed file system. HDFS means Hadoop distributed file system. Okay. So before going for this HDFS, okay, first of all we need to discuss about what is exactly file system, or you can say that what is file system first of all. Okay. So file system. File system is for store. What is the main concept of file system here? So just it is going to store some data. Just it is going to store some data. So now let us show that this is one desktop. Okay. And it can store how much amount of data it can store? 500 GB. Okay. So we can issue it is a Windows. It is a Windows system. Okay. So now here, so can we store this? I mean, can we store 200 GB of data? Yes, we can store. Can we store 450? Yes, we can store. Can we store 600 GB data? 600 GB of data? Definitely, we are not able to store. So only reason is, so its capacity is how much amount of data it can store. This Windows system, it can store only 500 GB. But we are not able to store this 600 GB of data. Okay, still we are able to store by using some, what we can say that, by using compression techniques. So here compression techniques means, so whatever the data in which we are having, so if we are having some different folders or different directories, each folder we need to make it as an either tar files or zip files or rar files, but it will take huge amount of time. Okay, so even we can store some 600 GB of data as well, because whenever if you are making some folders or directories as a tar files or zip files, so definitely it will reduce the size of the hard disks, right? So even we can store 600 GB amount of data as well. But if you're getting some 1 petabyte or 1 terabyte of data, definitely we are not able to store. So we need to go for a alternative. So that is nothing but external hard disks. We need to go with external hard disk as a storage device. But here, whenever this data is keep on growing on, so at some point of time, even we're unable to maintain this external hard disk as a storage device here. So for suppose if it is a 1 terabyte means, so we can store. If it is some 5 terabyte, so we need to purchase 5 more external hard disks, which were unable to store as well. First of all, I mean it was somewhat difficult, or it will take huge time to store as well. So if you want to store some 50 GB in external hard disk, so huge amount of time is required to store as well. Okay, I think, but these are the some limitations what we are facing in our existing systems, what are the systems which we are using daily, right? First of all, if you go with the file system concept, so let us assume whether it is a Windows or Linux. Windows or Linux. So each and every operating system, if you're going with the Windows or Linux, so by default they're having a concept called as a file system. Each and every operating system by default they're having a concept called as a file system. Yeah, I think, but file system is going to store some data. How this Windows system or Linux system, how they are storing internally means, so as a user, just we are discussing, just we know that it is storing in hard disk, but how at internally at backend it is storing is by using concept called as a file system. Okay, so like this it is storing internally here. First of all, so now we have got some conclusion. So what is the conclusion? Not each and every file system, each and every file system, sorry, each and every operating system. By default, they are having a concept called as file system. Example, if you are going with the Windows, FAT32 NTFS. Okay, and if you are going with the Linux, what is the default file system here? ext3 or ext4. Okay, these are the default file systems for the respective operating system. Okay, now this is the file system to store data, right? So now how, in which format it is storing? Okay, what is the format it is storing internally in file system here? So now here the format is here internally storing as a block. What is the concept? Internally it is storing as a block size. So now one more important point is note one. So the default block size in existing file system is 4 KB. So what is the format in which it is storing in internally is nothing but concept of block size. Okay. So what is the default block size here? Nothing but 4 KB. Nothing but here each and every block size is nothing but a 4 KB. This is 4 KB, this is 4 KB, and this is 4 KB. Okay. So now here we're having one file first .txt. Okay, so how much here? 2 KB. So this 2 KB file, it will store in this respective block. And what is the total space we're having? 4 KB, 4 minus 2, still we're having a 2 more KB, right? So now here we're having a one more file, maybe some Hadoop.txt with 6 KB as a size. So now anyway, so we're unable to store this Hadoop.txt. I mean, it is a 6 KB file. So we are unable to store in this remaining 2 KB block. So first it will store this data in this respective block. But what is the default here? Default block says here 4 KB. 4 KB is done. Still we're having 2 more 2 KB. Now this 2 KB, it is not storing in this respective block. Okay, whatever the remaining 2 KB from this text file, it is not storing in this respective block. So it is going for again new block. Means here what is the problem? What is the main limitation here? Memory size is wasted. So here whatever the 2 KB file or 2 KB size we're having, okay, which was unutilized, this space it is wasting here. That is the main limitation what we are facing in our existing file system. Okay, within a given block, if you are having some more size, so can we store any other file? Means it is not possible in our existing file system. This is the main drawback what we are facing in our if you go with the existing file system or in our Windows operating system. Okay, so again, what are the important 2 points here? First point is each and every operating system by default they're having a concept called as a file system. Means here if you go with the Windows, it is having its own file system, and if you're going with the Linux, it is having its own file system. Okay, and how internally, what is the format in which it is storing internally in file system concept is, so concept called as a block size. So by using block size concept, so it is storing the data internally in our existing file systems here. So now what are the limitations we are facing if we are going with this a single system? First of all, this is the complete file system concept, and these are the important points what we have discussed. And what is the limitations here? Second limitation is we are unable to store, or we can say that simply we can drawbacks or limitations in file system. So what is the file system discussed already? We are unable to store huge we are unable to store huge amount of data. If you are going with this diagram, we are unable to store huge amount of data. So whenever if you are not able to store, definitely we are unable to process as well, right? We are unable to process. We are unable to process huge amount of data. So, and because here we are storing the data in a single system, right? So there may be having some data loss as well. So in so many ways they're having some data loss. So first one is maybe some power failure, or maybe some system failure, or some network failure. Okay, so we are having a there is a chance of having some data loss as well. Definitely it will lose the data because we are storing the data within a single system. So it may be a crash, some unknown reasons, it may be a down, so many ways. Okay, there is a huge chances are there. So for data loss here. So majorly some power failure, system failure, and network failure. But each and every failures here, we're having a solution. So if you're going with the power failure, you can make with a backup, right? Okay, so you can use with some inverters or generators. And if you're going with a system failure, so that is the reason we can go with a concept called as a cluster. So nothing but within a single network, we need to maintain a group of machines or a group of nodes. That concept nothing but a cluster. So that this same data it can store in a multiple machines. Even though if one system is down, so there is no chance of losing the data as well. Or network failure. So network failure means you can go with the internets. So whenever if you are maintaining some 2 to 3 networks within a single organization, so if one network is down, so we can go with other network. So that concept they are implementing by using a switching networks. So if you are having concept of switching networks, even one network is down, simply it will shift to other networks here. But even we can solve that network failure problem as well. Okay, but still it is a problem whenever if you're going with a single system. Okay, and fourth one is metadata. This is very important. What is metadata here? Data about the data. What is metadata? Data about the data. So assume that here so in some drives, what are the drives which are maintaining in Windows system, right? We're having some couple of folders. First, second, third, fourth. So like this, I'm having some 100 folders. So in first folder, I'm having some images, audios, some text files, okay, some zip files, so many files I'm having. So as a user, today I can remember within this first folder, so these many images I'm having, okay, these many of audio files, or text files, or zip files. Today I can remember. After 1 month, there is a chance, but after after 1 year or 6 months, definitely we're unable to know in which folder data is present. I mean, data is present means types of data we're unable to know in the respective folders here. So I was unable to know. So this image I have stored in some folder, I was unable to know definitely. Or I want to know some text file. Definitely we're unable to know in this respective folder this text file is present. Whenever if you have a concept of 100 folders. Okay. So here the thing is data is present in a multiple folders. Here we don't have a concept that within this folder this data is present. That type of concept we don't have. So simply I can open, you can take some text file within this. If I go with this text file, if I go with this respective concept as an end user, I want to know. So these files present in this respective folders. These files are present in this respective folder. So like that, I don't have any concept. That is nothing but what is exactly metadata. Means data is present, but we don't know exactly where the data is present in a multiple folders. That's nothing but what is exactly metadata here. Data about the data, simple. Nothing but what is exactly metadata. Okay, so these are the limitations what you are facing in our existing file system, whether if you are going with either Windows or Linux. Okay, what are the limitations here? We're unable to store a huge amount of data. Whenever if you are not able to store, definitely we're unable to process as well. And next one is data loss. So there may be so many ways there is a chance of having some data loss here. It can be a power failure, system failure, or network failure. And fourth one is metadata. Nothing but data about the data. This is the best example. Okay, so these are limitations what you're facing in our existing file system. So now if you want to overcome these limitations, what are the limitations we are facing in our existing file system, right? So we need to go for a one more concept. We need to go for a one more concept called as, we need to go for a one more concept called as DFS. What is the one more concept here? DFS, distributed file system. Okay, so we need to go for a one more concept called as a distributed file system here. So one more point. So if you want to overcome the above limitations, we need to go for one more file system called as, one more file system called as DFS. Nothing but distributed file system. Okay, so if you want to overcome the above limitations, right, we need to go for it. We need to go for one more file system called as DFS, distributed file system. Okay, so is it clear till now, all of you? Any questions on this respective concept? So please let us know so that I'm going to clarify. Any doubts? Okay, so that's all for today. So I hope you have enjoyed this session. Okay.